In this lesson, we will work on finding the normal percentiles between two values. So again, we're looking at probability that a value falls between two values. To keep things simple, we're going to stick with our same example using SAT verbal scores as we did in the normal percentiles that we looked at previously. Here we're looking at a percentage of scores that fall between 450 and 600. Now this could get really difficult if we didn't have StatCrunch because you'd have to do some crazy addition, subtraction, etc. But here it's not going to be too bad. First thing you would do, if you want, again this is optional, is to draw a picture. It's good to visualize what it is that we're finding. So looking at this picture, it looks like about 50% fall between 450 and 600, but it's really difficult to tell just by looking at the picture. So we will find the z-scores, and of course to find the z-score we take the observed minus expected. So we'll take 450 minus 500 divided by 100, and we will take 600 minus 500 divided by 100, and of course I've worked those out ahead of time, which is negative 0.5 and positive 1. So what we're going to be looking for here is to find essentially the probability that negative 0.5 is less than z is less than 1. So it's very important here that you go in the proper order. Negative 0.5 corresponds to 450, that's the z-score, and this one is positive 1, and we always go from left to right. If you go from right to left, it's going to get crazy. So now I'm going to pop over to StatCrunch, and again I've got my 0 and I've got my 1, and I put in negative 0.5 and positive 1 and clicked compute. Notice the picture looks similar to my picture before, and that my probability is 0.5328. So back over here I can say that the normal model estimates that 53.28% of scores fall between 450 and 600. One more thing I want to point out, remember when we're showing our work here, we are writing our answer as a decimal. If we are writing it in sentence form, I'm writing that as a percentage instead. Now, just as before, there is a way to cheat in StatCrunch, which is just smart if you ask me. Cheating, I would put 500 and 100 just as I did before, and then again the lower value and the greater value, and notice I get the exact same answer, 0.5328, that I did before, and that's just being smart. Here are 3 questions for you to try. You may choose if you want to use the shortcut method or cheat method, or if you want to actually find the z-scores. I suggest finding the z-scores for good practice and then checking with our cheat method. So press pause, try these 3 questions, then press play to see how you did. So I'm going to go ahead and work through this using my z-scores. So for my first one, I've got an observed value of 15 minus an expected value of 24 divided by my standard deviation of 6. So 15 minus 24 is negative 9 divided by 6 gives me negative 1.5. So I've got negative 1.5, and I know that I'm looking for less than, so I'm finding the probability that z is less than negative 1.5. So let's pop over to StatCrunch, and this is standard, 0 and 1, and it's less than negative 1.5. And notice I come up with a solution here of 0.0668. Now in a little bit we're going to go back through and check these solutions again, but that's my solution for this one. For my second one, what percent of cars get between 20 and 30? So again, I'm looking at observed of 20 minus 24 divided by my standard deviation, which is negative 0.46 or negative 0.667, and a z-score of, or a value of 30 gives me 30 minus 24 divided by 6, which is 1. So I'm finding the probability that negative 0.667 is less than z is less than 1. And again, over here, I would choose my between function. I'm still using 0 and 1. I've got negative 0.667 and 1. And notice I get my solution here, which is 0.589. On the last one, again, I'm looking for a z-score, and I'm looking for more than 40. So 40 minus 24 divided by 6, which is 16 divided by 6, which gives me about 2.667. So again, over here, I'm going to go back to standard because it's no longer between, and I'm looking for greater than, and this would be 2.667, which gives me a small value because again I was looking for greater than 2.667 because it was more than, of 0.0038. So now I want to do all of that again, but I want to use my cheat method without using the z-scores. So here I'm going to use 24 and 6, and then I'm just going to plug all those numbers in again. So instead of negative 1.5, I'm going to plug in 15 and make sure that you change it to go in the proper direction, and notice I get the same value I did before. Then I'm going to click on my between, and that was between 20 and 30. So 20 here, 30 here. And again, I get the same value. And then for my last one, I'm going back to standard, and I'm looking at greater than 40. And I get the same answer yet again.